In this topic, we examined some general information about plant systems and fluids, and we described the basic structure of a liquid system. We also described energy conversions that occur in a liquid system. Now let's try some practice questions. In a plant, many different pieces of equipment work together to perform one or more jobs. Any group of connected components that function together to carry out a specific task can be referred to as a plant system. Control devices are also needed by a fluid system. They're basically mechanisms that adjust or change the operating conditions of the system. Control devices for a liquid system typically include control valves that start, stop, or regulate flow, as well as instruments that monitor and control operating conditions. When a constant flow of liquid passes through this narrowed section of pipe, the pressure of the liquid decreases and the velocity of the liquid increases. Different types of gas and vapor systems can be found in process facilities. Although these systems may look different and serve different purposes, they each have to have at least 4 basic parts to satisfy certain key requirements. For example, a gas or vapor system has to have an energy source to provide the energy necessary for the system to perform its task, a transmission path to transport the gas or vapor from one place to another, control devices to adjust or change operating conditions in the system, and components to carry out the specific task of the system, and in doing so, create a demand or load on the system. The basic structure of a gas or vapor system can be illustrated using a compressed air system. In a compressed air system, the energy source is normally an air compressor. The air compressor adds energy to the system in the form of increased pressure. The transmission path for the system is made up of all of the components that contain the compressed air, including the piping and hoses that connect the components in the system, as well as a tank called a receiver that stores pressurized air for systems and equipment. Control devices which adjust or change operating conditions in the system typically include valves and regulators that help control the flow and pressure of the compressed air. Instruments that monitor variables in the system are also examples of control devices. The compressed air system also has components that use the compressed air to carry out the system's function. As they do, they create a demand or load on the system. In this system, these components include air-driven or pneumatic actuators and pneumatic tools. Now try a question about the structure of a compressed air system. This actuator is part of a compressed air system. It uses air to position a valve that controls the flow of liquid in a pipe. Which basic part of the compressed air system is the actuator's operation associated with? Many of the gas and vapor systems in process plants have similar features. For example, many of them have pressurized storage tanks or pressurized cylinders to store the gas. Also, gas and vapor systems commonly use valves to control the flow of gases from the containers. Another component that's used in liquid as well as gas and vapor systems is a jet pump. A jet pump uses the flow of one fluid to move another fluid. An Erajector that uses steam to remove air and other non-condensable gases from a condenser is one type of jet pump. There are no moving parts inside a jet pump. Instead, the pump relies on energy conversions to operate. The jet pump shown here has a nozzle, a pump inlet, a combining chamber, and a discharge section. During operation, high-pressure steam flows into the nozzle inlet of the jet pump and passes through a restriction in the nozzle. This causes a low-pressure area to form just past the nozzle. The low pressure draws the gas being pumped in through the pump inlet and into the combining chamber where it combines with the steam. The mixture then flows out of the jet pump through the discharge section. So in a jet pump, flow energy, that is, energy that's related to pressure, is converted to kinetic energy in the nozzle, and the decrease in pressure that results from this conversion is used to pump the other fluid. Now, another device found in some gas and vapor systems is a condenser. Its purpose is to convert a vapor into a liquid by transferring energy. Inside a condenser, the vapor comes in contact with cool surfaces. In most condensers, the cool surfaces are tubes through which cooling water flows. Heat transfer takes place between the hot vapor that comes in contact with the tubes and the water that's flowing through the tubes. As a result, heat transfers out of the vapor, causing the vapor to condense to a liquid. As the vapor condenses, its volume decreases, creating a low pressure area. The drop in pressure draws more vapor into the condenser and enables the process to continue. Now, even though the low pressure inside a condenser is necessary for it to operate, it can also lead to some undesirable conditions. For example, there's always a chance that air will be drawn in through leaks or with the vapor flow. Air won't condense, and if it's allowed to build up, it can eventually fill the condenser and stop the flow of vapor. If this occurs, the condenser is said to be airbound. To prevent this problem from occurring, air removal systems, such as an Erajector, are normally connected to a condenser. A similar problem can occur if the condensed liquid isn't removed. As with air, if the liquid is allowed to build up, it can eventually block the flow of vapor. In this topic, we described the basic structure of one type of gas and vapor system, and we examined the operation of various gas and vapor system devices. Now let's try some practice questions. The basic structure of a gas or vapor system can be illustrated using a compressed air system. In a compressed air system, the energy source is normally an air compressor. The air compressor adds energy to the system in the form of increased pressure. Another component that's used in liquid as well as gas and vapor systems is a jet pump. A jet pump uses the flow of one fluid to move another fluid. An Erajector that uses steam to remove air and other non-condensable gases from a condenser is one type of jet pump. There are no moving parts inside a jet pump. Instead, the pump relies on energy conversions to operate.